Okay, I'm sharing my screen.
PRP দিছে নতুন একাডেমিক ক্যালেন্ডার 20 জানুয়ারি লাস্ট ক্লাস হয় নি কিন্তু কি করে মোর তো নভেম্বর পড়ছে তো পড়ছে নভেম্বর রিভাইজ অলরেডি রিভাইজ দিন আমি পড় বছরে পড়ানো
Screen is visible now. I shared a problem 1. The cantilever beam is subjected to a various load as shown in the figure. Screen is visible? Okay.
Yes, ma'am.
Okay. So today we'll discuss this problem, okay? So a cantilever beam is given and there are combination of two loads. One is UDL and others are point loads. 1 kilonewton, 5 kilonewton. These are the points load given at some position. And this UDL is 2 kilonewton per meter. Okay. So we need to draw the shear force and bending moment diagram of this beam. And if you see this point load of 1 kilonewton is at a distance of 0.5 meter and another 5 kilonewton is at a distance of 1 meter, total 1 meter from A and 0.5 meter from this 1 kilonewton. Okay, and this 2 kilonewton is over the whole span. So what will you do? First, consider a section XX dash at a distance x from section B. Okay, we are considering a section XX at a distance B on the beam at a distance of x. So shear force at Fx will be, so for UDL you know shear force is W, this W into this W into X. Okay. So at X equals to 0, your FB will be 0. At X equals to 1, your FB will be 2 into 1. Shear force between D and C. That means your D and C. The shear force between these 2 points, it will be like Wx plus 5. Why? If I shift this X position, let me, if I shift this X position here, what will be my new shear force? It will be Wx, okay, because W is over the whole span, Wx plus this point load 5 kilonewton. So this will be my shear force for when I draw a section at this position. First, I draw first section at this here only UDL was present. That's why my shear force equation was W into X. When I take the section at this position, the shear force equation becomes W into X plus 5. This 5. Again, if I take a section at this position, my shear force will become Wx plus 5 plus 1. Okay, so let's see. Between shear force between D and C, this is my shear force equation. Replace the value of X at X equals to 1 meter, at X equals to 1.5 meter, these were my shear force. Now between C to A, this is the shear force equation, Wx plus 5 plus 4. Replace the value of X 1.5 and complete 2 meter, I'll get this point. So these are my shear forces. I have to draw diagram with these values. Okay, with these values. If you see the shear force diagram, they are placed at A 13 kilonewton. So see at A that means at 2 meter distance my shear force was 13 kilonewton. At X equals to 1.5 meter it was 12 kilonewton. So like this 13 kilonewton, 12, 8, 2, and if I join the points, this is my shear force diagram. Okay. Same with the bending moment diagram, you will take the same position, bending moment between C and A. That means bending moment between this C and A. What will be the bending moment? Force into this distance. So W into X. This is the force. What is the distance? X by 2. Right. Now when you take another section, this will be the Wx square by 2 minus 5 x minus 1 minus 4 x minus. That means at x equals to at this position. At this position, and they have found out the bending moment at this position. Two positions they have found it. Okay. So this is the bending moment equation, Wx square by 2 minus 5 by x minus 1 minus 4 by x minus 1. So if I replace the value of x, I'll get this value, and at x equals to 2 meter, I got this value. So place, this is my shape of bending moment diagram for this question. Okay. So try to solve by yourself this question. Try to solve this question by yourself. Now, try to solve this question by yourself. Try. Try to solve this question by yourself and let me know the answer, or you can yes, let me know the shear force values and bending moment diagram. Try. Same cantilever beam, UDL is not over the whole span, UDL is over this span. Okay, here only one load is acting. So you can take a section, only one section will be enough here. Okay, only one section will be enough. Find the shear force and bending moment and place the value of X here. So it will be easy to find. So all of you try by yourself. So have you found out? So consider a section at XX at a distance x from the end B. I'm considering the section XX from B. Okay. So shear force will be W into X. So place the value of X equals to 0. Your shear force will be 0. And at X equals to 1.8. Because your UDL is still 1.8, right? So X equals to 1.8. My shear force is 108 kilonewton. Since there is no load between point A and C, for this region Fx remains constant. That means for whatever we got FC at FC position, at this position the same shear force will be from this to this, as there is no any load. Okay, so same 108 kilonewton. The sign is taken to be positive because the resultant force is in downward direction on the right hand side of the section. Now bending moment. Again, I'm taking the same section here. What will be my bending moment? Force is W into X and the distance X by 2. So this will be my bending moment, Wx into X by 2. So this is the equation of bending moment. Place the value of 0 to 1.8 meter. These are my bending moments. And from region C to A, this will be the bending moment. W into X. Now X will be X minus 1.8 by 2. The whole length. For bending moment, there will be two sections. One section will be here and one section will be here. Okay. So for this section, this will be W into X into this X minus 1.8. Suppose for bending moment, this will be my section. Okay. Equation will be W into X into X by 2. This W into X into the distance. X minus, suppose this is my X. Suppose this is my X and this is 1.8. So X minus 1.8 by 1.8 by 2. Okay. So this is my So this will be my bending moment equation from region C to A. So at x equals to 1.8 meter, this is the moment value, and at x equals to 2.5 meter, this is my moment value. Okay. So this is just simply put the values, join the lines. This will be your shear force diagram. This will be your bending moment diagram. Okay. This is a straight line as there are no loads, and this is a parabolic because of UDL. Okay. Usually UDL, wherever UDL is present, your bending moment will be mostly parabolic. So try this one. If I solve each and every question, how will you perform? So this one is very simple, right? Some part of the beam is loaded with UDL. Some part of the beam is overhanged. Okay, some part of the, so you can take a section at here, or you can, and one section you can take at this position. You can take two sections. So you have to carefully choose the section. You can take one section at here, and you can take one section at here, and find the shear force equation. Place the value of x, and place the value of find out the bending moment equation. Place the value of x. You'll directly get equation. Try this one. Try this one. Are you able to understand what I have discussed so far? You can type in the chat box if you have any confusion in the previous questions.
Ma'am,
Please type in the chat box, otherwise it will create echo. Type in the chat box. Any issue, please type in the chat box, huh? Otherwise it create echo echo in the video for recording. Any issue, you can type in the chat box. Why the bending moment is in previous question is negative? The first one or second one? This one, right? Anti-clockwise. The moment is your anti-clockwise. Maybe if we are if based on your section direction of the you consider the direction of movement you consider. Maybe they have considered the movement here. Let me see what they have considered the direction. The sign is to be taken to positive because the resultant force. Okay, not this one. Movement for movement. See, they have taken the clockwise movement as negative. Okay, if they are taking clockwise movement as negative, that's why negative. See, this is my load. This is my load. Let me. This is the beam. This is my load. Okay, UDL, and this is the distance. So in this question, they are taking this clockwise direction as negative. That's why. Okay, it's up to you. If you are consider, you can take anti-clockwise negative or clockwise negative. It's up to you. But you have to consider the same sign convention in the whole one problem. If you are considering in this problem clockwise as negative, so take as negative. Any issues? Okay, so try this one. Your some part of the beam is overhang. Okay, some part of the beam is overhang and it is placed between A and B, UDL. Then try to find out this one. This lecture is in. Okay, I'll share the lecture also. Tell me the notes. Try to solve. Let me explain this one. No one replies. Okay. So by taking moment of all the forces about A. So in, in simply supported beam, in why we have not founded the reaction in cantilever beam, we know that at free end there will be no reaction. So for the simply supported beam, they first found out the reactions RB and RA. So if I take moment about this point, which what will be the moment RB into 3, right? This WX into this distance, RB into 3 minus the UDL into W by 2, this W by 2 into 4 square. So equals to 0. Taking moment of all the forces about A. So I'm taking the moment of all the forces about A equals to 0. So one will be this reaction RB into 3 minus this load W into this, what is the distance? 4 by 2. So this how they got the RB. For static equilibrium, summation of all the vertical forces will be equal to 0. So this is the vertical forces equals to 0. I've got RA is this. So I've first found out the RA and RB value. To draw shear force diagram, we need shear force at all silent points. Now taking a section between C and B. That means I'm taking a section between C and B. I'm assuming this as C. The overhang part, I'm taking this overhang part as C, and I'm finding the shear force between this and this. So I'm drawing a section of x1x at between these two points. Now after taking section between C and B, shear force at a distance x we have at x equals to 0. That means at this position there will be no shear force. Okay. Now taking distance between B and A at a distance x from the C end. At x equal to this is my at x equal to 1 meter, my force will be only W into x, right? At extreme point, my shear force will be 0. At this point, between B and C, there will be two boundary conditions between B and C. Between B and C, my shear force equation will be W into x, right? Now, at x equals to 0, this will be at equals to 0, this will be at x equals to 1. So place the value of at x equals to 0. That means at this position, if I place 0, my shear force will be 0. At x equals to 1, my shear force will be W into 1. Yes? So this is how. At x equals to 0, my shear force is 0. At x equals to 1, that means at a F shear force at B, it is 1 into 1, 1 kilometer. Load was 1, distance is also 1, so 1 kilometer. Now I'm taking the next section between B and A. That means between this B and A. If I take a section at this position, what will be my shear force equation? So this will be my shear force equation. 4 minus x by 3, 8 by 3. Why force? this distance, and 1 into 4, between A and B. Between A and B, my shear force equation will be W into X. If I take a section here, huh? So it will be W into X minus this RB. This will be my shear force equation. Now what is W? It is 1. What is the whole distance? If I take this will be my shear force equation, and if I take at x equals to 4 meter, it will be 4 minus RB is your 8 by 3. So it will be 4 minus 8 by 3. Okay. 4 minus x by 3. So this is at x equals to 4 meter. This is my distance. The shear force becomes 0 at x equals to 2.67 meters. The same way, you have to take two sections to find out the moment. This will be W into x by 2. So if you place the value of x, you will get the moment. And we know at C, at the free end, the overhang part, the moment will be 0. Okay. You can find out the maximum moment. The maximum bending moment occurs at a point where dmx by dx equals to 0. So place the value of moment equation. If you derive it, you will get the 0, and you will get the distance where your bending moment will be 0. That is x equals to 8.3 from the end C. Place the value of x by 3 in this equation, you will get the maximum moment. This is also called as point of contrafracture, where your moment is 0. So this is your final shear force diagram, and this is your final bending moment diagram. There are many more questions. I'll share this PDF. Okay. Till here. Okay. The last till question number 4. You try to solve by yourself, or I'll share this PDF to see the solution. If you don't understand, we'll discuss in the next class. Okay. Yeah. These 4 questions are important. Okay. So all of you write your roll numbers in the chat box. All of you wrote their roll number. Anyone left?
No, ma'am.
Okay. So thank you. I'll share the next
Ma'am,
link. Yeah.
ma'am, we have exam on 16.
Not sure. I'll let you know if I get any notice.
Ma'am, according to that revised schedule they gave us, we have session exam on 16,
Okay.
from
Okay.
16
Okay.
onwards.
Let me ask them our PC sir. I'll inform you in the group. Okay.
Okay, ma'am.
So Thank you. I'll share the next meeting link. Okay.